In today's lesson, we're going to identify slope and y-intercept and graph linear equations. Here are some preliminaries on slope, y-intercept, some things that you might want to jot down. M represents the slope, B represents the y-intercept, and the slope formula, if we're given 2 points on a coordinate plane, we can use those 2 points to find a slope by using y2 minus y1 over x2 minus x1. And then the main focus is to write these equations in slope-intercept form. It's much easier to graph a line on a coordinate plane if you can get it in y equals mx plus b form, which, by the way, if you notice, y, the variable y, is by itself. So anytime we say get y by itself, we're going to graph, you're trying to get it in slope-intercept form. Another thing to think about with slope, m, it's rise over run. If we go back and look at the formula y2 minus y1 over x2 minus x1, the y's are your rise and your x's are your runs. Another thing to note about run is when you graph a point from another point using the slope, rise over run, if it's positive, if we have a positive slope, you're going to go up, however many units it says, and then the run is always to the right. Okay? Now, let's say we have a negative fraction. What if we have a negative slope? Negative is down from a particular point, and again, the run is always to the right. Okay. Now, sometimes you'll run into a slope. Let's say you see a slope m. It's just the number in front of x. Well, if we had a slope of 3, if there's not a run, you put a 1. Not one there, put 1 there. It's okay. 3 is the same thing as writing 3 over 1, because this little line of mine tells me divide. 3 divided by 1 is still 3. Okay? Alright, so what I want to do here is kind of go through some examples. We're going to graph these on a coordinate plane. So if you could, go ahead and jot these down, these 3 examples. You can pause the video. That way I'm not wasting too much time here. Here's example 4. Now, with example 4, we're going to graph using a table. 3x plus 2y equals 4. And we'll add to this right in slope intercept form. Okay, I'm not a neat handwriter. Miss Seidel wrote some of this, and I'm writing some of it now. You can tell which is which. Alright? So, example 1, we got y equals 2x plus 3. I'm going to have to draw up a coordinate plane. Alright, so here's a coordinate plane. I'm going to draw the y-axis and the x-axis. Make sure you know which is which. Okay? And we were graphing y equals 2x plus 3. So I'm going to write that somewhere right here. Y equals 2x plus 3. Now, all you need to be able to do is understand what slope-intercept form looks like. Well, y equals mx plus b. Right? So from this, I can identify my slope, which is 2, the number in front of x, and my y-intercept is 3. It's positive 3. Okay? Now, a little side note here. What I like to do first is there could be a lot of lines with that slope of 2. Okay? What I know for a fact is my y-intercept is positive 3. Okay? I'm going to probably run out of room here. I'm going to go ahead and plot. I'm going to go ahead and plot that y-intercept first. So your first step is, once you know the slope and the y-intercept, let's plot the y-intercept. It ain't going to go anywhere. Or isn't, sorry. And then from this point, we can use the slope, which I don't have a run. I'm going to put a 1. Okay? And that's a positive fraction. And from this y-intercept, I want to count up 2 and go over 1. Always to the right. Run is always to the right. Once I do that, I can plot another point. Okay? Once I have 2 points, okay, you're okay to draw a line through those 2 points. I'm trying to draw a line through those 2 points. I can't make it look pretty, so I'm just going to make it look sloppy. And there you have it. So we just graphed our first line just by identifying the slope and the y-intercept. Okay? Now let's go back to example 2 here. Okay, negative 1/2 x plus 2. Alright, so y equals negative 1/2 x plus 2. Let's draw up another coordinate plane. Alright, so here's my x-axis, here's my y-axis. Okay, that's negative, by the way. Oh, that's terrible. So let's identify my slope. Negative 1/2. Okay, I got a rise and a run. Okay, it's negative. So you can literally put that negative in front of 1 just like this. Okay, leave the run alone. It should be positive. It's a negative fraction. It's not going to matter. Okay, so now we got b. The y-intercept is positive 2. Again, I'm going to plot the y-intercept first. Okay. Basically, I'm just going from the origin here. The origin is the point of intersection of the x and y axis, 0, 0. And I'm just going to go up 2 spaces from that origin. Alright? Let me get rid of that pink dot there. And then use your slope to find a second point. Now, since it's a negative slope, I'm going to go down 1 unit. Wrong color. Down 1, and then the run is actually 2, so I'm going to count over 2 spaces. Okay, I got 2 points. Draw you a line. Alright. So, there's example 2. Let's take a look at example 3 here. Example 3 is y equals 4. Be prepared to run into these. These are actually pretty simple. Y equals 4. Okay. I want to write that equation down. It's in slope-intercept form. The only thing is, we're missing the x variable. Okay. So I don't have a slope. I do have a y-intercept though. Okay. If you wanted to rewrite this equation, you could write y equals 0x plus 4. Okay. Why can I do that? Well, what's 0 times x? 0. You know, you can put any number in here for x, and it's not going to matter. 0 times that number is going to be 0. So, I can identify this part as the y-intercept. which I could plot. Put my x-axis, y-axis. I could plot that point right here. But let's kind of start over here on this graph with y equals 4. If you really want to think about it the easy way, okay, you know y equals 4. Well, if I'm plotting points, I know y equals 4 right here, right on the y-axis. Well, here's a y equal 4, here's a y equal 4, here's a y equal 4. All these have a y coordinate of 4. It doesn't matter what x is. Remember what I said about x. X is 0, does not exist. Okay, I have a flat horizontal line. Okay, that's what y equals 4 looks like. Now, what would happen if I had x equals -2? Okay, I'm going to graph this on the same coordinate plane just to save a little bit of time. Well, if I'm on the origin and I'm trying to find the x at -2 on this line right here that I just highlighted in red, okay, I can actually go left, -2, just like on a number line. Okay, doesn't matter what y is missing. X equals -2 here, x equals -2 here, x equals -2 here, x equals -2 here, and here, all the way up and down. Now, I have, not a beautiful straight line, but I have a vertical line. Now, the slope of x equals -2 is referred to as undefined, and the slope for y equals 4, since it's a flat horizontal line, is a 0 slope. Okay? Alrighty. Guys, anytime you get to a point you need to pause the video and write down whatever you need to write down, do it. Alright, now what I want to do is I want to graph using a table, but I want to add to this. I don't like looking at something that's not in slope-intercept form. It's hard to read. If you can identify the slope and the y-intercept, it's really easy to graph, because that's our whole goal here, right? We want to graph. And we're going to use a table. Okay, and what that means is, that's exactly what it means, actually. Let's look at 3x plus 2y equals 4. Alright, this is going to test your algebra skills from last year. We want to get what by itself. Think about what we talked about in the beginning. We want to write it in y equals mx plus b form. Okay? I need to get y by itself. Now, I don't know who's told you what, but I invented this approach here. Box it, line it. Okay? Now I'm going to get y by itself using that. I'm not going to really mess with y yet. I'm just going to kind of leave it alone. I want to take everything else to the other side. Say, in the process, you got to do the opposite. Opposite of 3x is minus 3x. Be fair, do both sides. Okay? Cancel out. Can't really add these like terms here. Guys, I'm going to assume that you know what like terms are. Negative 3x plus 4. Bring down 2y. Okay, well now I can get y by itself. Well, what's being done to y? It's being multiplied by 2. I need to do the opposite and divide by 2. Okay, so let's do each term. Okay, we're going to divide each term by 2. That cancels out. Now I have this fraction here, negative 3 over 2x plus 2. And guys, there's all sorts of ways of doing this. One we already got this equation in slope-intercept form. I know the slope is negative 3 over 2, and the y-intercept is 2. It's positive 2, so if you want to write that down, that's fine. Alright, now what I'm going to do is go ahead and draw a coordinate plane. Alright, here's my x-axis, here's my y-axis. It's not writing. Now, I'm going to go ahead and look at these two things right here. I'm going to plot my y-intercept. That's the first thing that needs to go, is positive 2. Now, since I'm negative from my y-intercept, I'm going to count down 3 spaces. So I know you can't really see it. I know you can. So it's down 3 spaces from the y-intercept, and you go over 2. Okay, so there's that second point. Now I'm going to go ahead and draw my line. Oh boy. That's a little bit better. Not bad for freehand. Okay, now what I'm going to do is, let's draw a table. Okay, and what that table is going to look like is, I'm going to write this in different colors. Let's go orange. Alright. We're going to write a table starting with x. Okay. I'm going to put y here. And I'm going to put xy right here. Alright. Now, what I did with slope-intercept form, I had this right here, y equals negative 3 over 2x plus 2. I'm going to write the negative 3 over 2x plus 2. Okay? And it's all about plug and chug. Now, will you have to be able to use a table? Yes. Do you have to use a table every time? No. Okay? But it is helpful to understand what's going on with these linear equations. Now, if you have a fraction as a slope, which we did, I got a little trick to avoid you dealing with fractions. Whatever that run is, our run was 2, I'm going to write the positive and negative version of that right here, because I'm just going to do 3 x values. The rest, I may specify what x values to use, but if you see the run is something other than 1, like in this case 2, I'm going to use the positive and negative version of that number, and all I'm going to do is just plug and chug. Negative 3 halves times 2. That's what we're plugging in for x, plus 2. When you punch that in, that should give you negative 1. Now we just created a point. 2, negative 1. Notice I put x first. You can actually do this. Okay. Fill in the table. Alright. Now I'm going to go ahead and go through the rest of the table here. Alright. Plug that in. That will give me 2. Oh my goodness, that should look familiar right there. 0, 2. We're going to look at it here in a second. Negative 3 over 2 times negative 2 plus 2. The 2's cancel out. Negative 3. Okay, that's positive 3. That should be 5. Okay, so there's my y values. Here's my points. Now we got 2, negative 1. Let's find 2, negative 1. Oh my goodness, it's right here. 2, negative 1. Folks, it's a miracle. Okay. Alright, let's see what else we have. We have 0, 2. I don't need to crawl anywhere. I just need to climb. 0, 2. Oh, my goodness. This guy's on fire. Alright. So there's 2 points. So we're finding points that exist on this line. Let's see if we can get the last one to work. -2, +5. Alright, -2. I want to start my origin here. Go -2 this way was the x. And +5. 1, 2, 3, 4, 5. Oh boy. It's kind of ironic, isn't it? Alright, gang. I think that's enough for one video. We'll see you in class, or Miss Side will see you in class. Any questions that you would like to ask, have them jotted down in your notes so we can address them before we move on. Thanks.